to Atherosclerosis podcast, the series hosted by the E10 Young Fellows. I am Emiel van der Vorst, and I'm joining you from the Department of Internal Medicine 1, Cardiology, at University Hospital Aachen in Germany.
Hello, I'm Tatyana from the National Therapy Institute in Ukraine. This episode is a bit different. We are trying something new today. It's our first time recording remotely and co-hosting together.
In this episode, we've invited Professor Christoph Binder. He's a specialist in laboratory medicine and currently deputy head of the Department of Laboratory Medicine at the Medical University of Vienna.
Christoph Binder's research interests span vascular biology, lipid oxidation, and innate immunity. His group investigates the immune mechanism of atherosclerosis, with a special focus on the role of innate and humoral immunity, and how this can be exploited for the treatment of cardiovascular disease.
From 2016 to 2019, Christoph Binder was a member of the executive committee and until recently vice president of the E10. He also is a PI of the Austrian Familial Hypercholesteremia Registry, and since 2014 he's a board member and since 2024 Vice President for Biology and Medicine of the Austrian Science Fund.
Hello, Professor Binder. It's a real pleasure to have you on Atherosclerosis today. This introduction was just a glimpse into your impressive work. Would you say it captures who you are, or is there anything would you like to add?
Yeah, hello, I'm happy to be here and thank you for inviting me. I would say almost. What I consider to be really key to who I am in my professional career, not so much my functions, but probably rather what brought me there. And that includes, of course, the fact that I spent a substantial amount of time and training, and I even started my professional career abroad in the US. And there I had an exceptional mentor with Joe Widston. And I really owe him a lot, as well as, of course, the many colleagues and co-workers throughout the years. Some of them have actually become real friends. And I think I would be a different person without these experiences and these people. So I think this is what I think has to be added.
I think this is already a very good addition, and I'm glad you bring this up because we will also come back to this aspect later on during the podcast. But let's start with something we are all curious about. Could you maybe walk us through a typical day in your life? How do you manage to balance your research, your leadership responsibilities, as well as your role within institutions like the E10?
It really depends a lot on the day, of course. But in general, I start in the morning answering emails and doing some phone calls. And then mostly in the morning, we have regular meetings such as lab meetings or progress reports and other regular meetings. And then the afternoon is more dedicated to focusing on reviewing papers, working on manuscripts. But that would be sort of my preferred day, I would say. Then I have other days where I have a lot of administrative work and days with university commitments and lectures. And there's even some days when I still do clinical work, which in my case is laboratory medicine. But all of this, of course, is disrupted by all the other duties that you mentioned for journals and societies such as the E10. I'm not sure there is a recipe for how to balance all this, but you rather learn how to deal with it along the way.
Fantastic. And building on that, do you have any advice for those aiming to or starting to manage multiple responsibilities, especially while running a lab in parallel?
I would try to avoid it as long as you can. There's often really too little satisfaction in it, and it comes really with the job. So it's a necessary part of your life, of your professional life, because you want to have somewhat an impact on how things are done and how maybe your institution develops. But if you take on these responsibilities, I think my advice would be to make sure that these activities don't take over your entire professional life, because that can easily happen.
Maybe also more on a personal note, do you have any hobbies or activities you enjoy outside of research that help you unwind and also take your mind off work?
Yes, I do enjoy going to the theater and classical music concerts, and this is, of course, easy in Vienna. And otherwise, I like to go skiing in the winter or swimming in the summer. And recently, I actually started again to play tennis. But I think what I think really is important, you need to make an effort to do these things outside of work. Otherwise, you can easily get stuck never having time for it. So I think it's important to have these activities on the side.
I think it's really inspiring to hear about the human side behind the science. But now let's dive into your scientific journey. Could you tell us more about your academic path? What led you to focus on the role of the immune system in atherosclerosis? Was there a specific moment when you realized, this is a field I want to dedicate myself to?
So I studied medicine in Vienna, and then very quickly I moved to the US, to the University of California, San Diego, to obtain a PhD. Because back then, we did not have this option to have a focused PhD program for MDs in Austria, and I also wanted to go abroad. So I ended up in San Diego, had several options, and there I joined a PhD program where we had to do these lab rotations. And after my first lab rotation, I actually joined Joe Whitstam's lab, who of course is a very well-known scientist in atherosclerosis research. And I really ended up staying in San Diego for nearly 9 years. So I'm not sure there was a decisive moment, but I knew that I always wanted to do basic research during medical school already, and I just slowly grew into this specific topic. So, for example, my first paper, which I did in medical school, actually, it evaluated the role of lipid peroxidation in kidney disease, in glomerulosclerosis. So when I then joined Joe Whitstam's lab for the lab rotation, there was some familiar ground, because he, of course, together with Dan Steinberg, had proposed the oxidation of LDL makes it atherogenic. And then I had always an interest in cardiology during medical school, so atherosclerosis research was a good fit in a way.
Yeah, very interesting. Based on your work and your focus so far, you have a large focus on natural antibodies, innate immunity. Do you have a favorite immune cell or molecule that you're especially interested in?
I really think antibodies are amazing molecules. On the one hand, because they are major mediators of the immune response, of course, but they're also amazing tools for therapies and diagnostics. So the versatility of antibodies, or let's say the antigen binding site, the variable region, still astonishes me. There's, for example, CAR T cells, among others, where you can exploit exactly this property of B cell receptors to target these cells specifically to specific other cells or sites. I think this is really an amazing molecule. What excites me about the natural antibodies is the fact that they are variable regions, so their antigen binding sites are evolutionary selected, both to function in host defense, but also to play a role in homeostasis, which is why we think they play a role in atherosclerosis. So the structures these antibodies recognize are really conserved structures, but we're still far from understanding the homeostatic functions these antibodies play in particular.
Right, it's very interesting. But I have a question in a little bit in another direction. So excellence doesn't come for free, as we know. And the journey to become an expert often requires significant sacrifices. Do you think the way we currently train physician scientists sets them up for burnout rather than success? And on a personal level, was there ever a moment when you seriously considered leaving your training or research altogether?
Yeah, this is a very important but also complex question. We are asking this constantly ourselves in academic medicine. Well, I think it's important to understand that the career path of a physician scientist is not for everyone. And even among the ones who choose this path, one needs to find individual arrangements, as the way it was done before is clearly not compatible anymore with today's concept of work-life balance, but also clinical medicine, in most specialties at least, has different and more demands than it used to have. So in my opinion, maybe it comes down to two things. On the one hand, you really have to want it, and need to be passionate about it. And on the other hand, you actually need a supportive environment. Without that, I think it's almost impossible. So the supportive environment is key. The second part was whether I ever doubted my decision. Well, not really, to be honest. But when I returned to Vienna after my long stay in the United States, I did my clinical training here. and at the same time started a research labs. And at that time, I had really moments when I was considering moving back to the US because it was really quite tough and probably one of the most challenging periods in my life.
So as ES fellows, we are of course glad that you stayed within Europe. So looking back in our 8 episodes, we interviewed Marty Kiss, who works in your lab, and he mentioned you as his most impactful mentor so far. We have 2 questions for you, and you already mentioned Joe Whitson being one of your main mentors that shaped your journey. Is there any other mentor that really shaped this? And secondly, also, how did you yourself develop such a strong skill to also mentor others?
I will mention Joe Whitson again, of course. He was a tremendous mentor, and we also became good friends. I actually still ask him for advice today. But there are other mentors. One of them was Doncho Kariashki. He was the chair of pathology, and he asked me to join his research lab after my pathology exam in medical school. And later also Oswald Wagner, who is my department chair, and he did exactly what I mentioned before. He provided me with the environment that allowed me to grow and build my lab while still obtaining my clinical training. So I think these are really key people in my professional career. And I think the skills for mentoring you learn by example. And I was very lucky to have very good examples. And I think this is what I would see as the most important way you basically learn from your own teachers.
And now speaking as your fellows, we just want to take a moment to thank you. This past 2 years, and I think almost already 3 years actually, have been an incredible journey, and both scientifically and personally. And your mentorship had a huge impact on our careers, and we are deeply grateful for that. But we have always been curious. What kind of impact do fellows have on you as a mentor and researcher? What do you take away from these mentoring relationships?
Yeah, thank you, Tatyana. Of course, I have to say that among the many different extra responsibilities I have in my professional life, the Young Fellows program has been always my most favorite one. And this would also be my answer to your question about balancing different responsibilities. There is actually, or there can be, tremendous satisfaction and joy in mentoring. I guess, as I mentioned before, if you have an impactful mentor yourself or had this, you feel the urge to also pass on this experience to others. And on a research level, mentees often come with the most inspiring and revolutionary ideas, and sometimes they are maybe out of ignorance because they're so young, but in most times they have a new look at old questions where you may be stuck. So it's really a mutual benefit, at least to me.
This is very nice to hear, I think, for us, but also for the future young fellows. And so coming back a bit more to the science, can you maybe tell us also a bit more about your Duke Foundation network that you're coordinating called the B cells in cardiovascular disease? We're curious, what are now the main goals and what has been achieved so far, but maybe also what are the main challenges and benefits of coordinating such a large consortium?
Yeah, I mean, the Leduc Foundation is really an amazing foundation and tremendously well organized in supporting international or transnational research networks. So we, as you know, have a long-standing interest in understanding how B cells and humoral immunity, for that matter, influence atherosclerosis. And then together with Phil Swirsky, who is the American coordinator, we put together a network of researchers that who wanted to tackle this specific aspect of atherosclerosis research, or the role of immunity in atherosclerosis. So on the one hand, what we wanted to do there is really to map the B-cell responses in atherosclerosis, both in the preclinical models, but also in humans. And I think we did quite well in trying to sort of understand the role of different subsets of B-cell responses. But on the other hand, of course, which is very relevant to us, is we wanted to also find ways how we can exploit these B-cell responses for therapeutic interventions using some very innovative approaches, for example, RNA-based therapies. So if you ask me what are the challenges in coordinating this, I would say the most challenging part is to keep the network going and keep it focused. And I believe we did this quite well by providing support for young trainees by means of mini grants, which generated an amazing momentum. And that was really a super tool that was possible with the Ludwig Foundation.
And as an expert in immune responses in atherosclerosis, what is your vision for the clinical translation of this field? Do you think future score and risk equations will include measures of inflammation? Do you think, for example, it will be the case for specific subsets, such as chronic inflammation, autoimmunity?
I'm convinced that at some point we will include measures of inflammation and or susceptibility for inflammation in our risk assessment. Whether this will be CRP alone, I'm not so sure. And there will be more biomarkers eventually that will help us stratify patients and really identify those who will benefit the most from anti-inflammatory therapies, or maybe better, actually, immunomodulatory therapies for ASCVD. So I think yes.
If you think about the list of the so-called non-traditional risk factors, it has been growing over the recent years quite a lot. So in your opinion, what are the most important ones, and maybe also what's the most important knowledge gap that still exists in this area?
Yeah, I agree. Now that we are able to lower lipids and control other risk factors so efficiently, and it's really more a problem of implementing this, the other non-classical risk factors are gaining attention, and this is important and relevant. In my opinion, we probably will see a set of different risk factors that may have different impact on risk depending on the individual. So while in some patients maybe certain inflammatory pathways may be more relevant, in others the residual thrombotic risk may be key, and so on. So what we really need to do, we need to identify the right biomarkers for all these different aspects. As I mentioned before, CRP is certainly not the answer to determine inflammatory risk. And we, for example, do not have a single biomarker to assess thrombotic risk. So I think this will be important, and these are the knowledge gaps. And of course, there's the psychosocial factors such as sleep and stress that are clearly also very important, and we still know very little about the mechanisms behind that.
Thank you for sharing this. And actually, that leads me to my next question. Given your expertise, what would you say is the most critical question currently in atherosclerosis research?
Yeah, to me, one of the questions I think a lot about is, can atherosclerosis be eradicated if everybody receives optimal and timely control of their risk factors? So probably yes, but this will certainly take some time. So the implementation of all these preventive measures that we know is critical. That said, I do think that it is critical to see if there are actual different disease variants within atherosclerosis, depending on individual susceptibilities for, let's say, certain pathophysiological contributors such as inflammation. And we have always focused so much on risk factors and the mediators of disease. I think we also need to focus on the protective factors or resilience factors that exist to fully understand why disease manifests in one but not the other patient with a apparently similar risk factor profile.
If you think about some booming new therapies, are also the incretin-based therapies like GLP-1 receptor agonist, and their role and protective role on the cardiovascular system. Can you enlighten us? Is there also a profound role of the GLP-1 receptor agonist on the immune system, maybe also specifically on the complement and the antibody production?
Yeah, I mean, I'm not an expert in this, but it's an amazing development. And these drugs seemingly work in nearly every disease, including atherosclerotic cardiovascular disease. To which extent this is mediated by direct anti-inflammatory effects is probably debatable, and certainly it's not really understood. But I'm also not aware of direct effects on humoral immunity. If there are effects, they may be rather a consequence of the associated weight loss.
We also know that your group is studying extracellular vesicles. Can you tell us more about their potential use as biomarkers and therapies?
I think that's a good question. I think the concept of extracellular vesicles is intriguing, as these could really be important endocrine, paracrine, and autocrine amplifiers of different molecular functions, of course. For example, they can propagate inflammation, which is an aspect that we're interested in. But the main limitation is that it is really difficult to reliably measure these in the blood. At least these are very elaborate procedures that make it simply impossible, for example, to translate it into clinics. There have been actually attempts to simplify these assessments, but these have not been successful. And there's also pre-analytical issues, how the blood is drawn, and that could actually confound the measurements of these. So it's a difficult part of research when you're thinking about translation here. The main caveats, of course, I would say, are the official criteria for measuring EVs. So there is a society that makes these criteria, and one needs to adhere to them for publication. And these are really almost impossible to adhere to, and rather hinder research than they help, in my opinion.
Early on, you already mentioned the CAR T cells as a potential new target or therapy approach. And of course, also B-cell directed treatments, they're really transforming medicine at the moment. Can you elaborate, what are your thoughts? What is now the most promising approach that's currently being developed, also, for instance, within your the Duke network? And in line with this, also, what's the biggest limitation at the moment to really bring these approaches into the clinical practice? Is this the science behind them, the regulatory process, or is it a mindset?
I think there's all different aspects and contributors to implementation of these therapies. Although, for example, RNA technologies have now become more acceptable, especially in the cardiovascular fields. We have a lot of RNA-based drugs, and the RNA-based vaccines, of course, during the COVID pandemic have changed how we look at this. But in atherosclerosis, as it is a chronic inflammatory disease, I would not see so much promise in these radical immunotherapies that need to be administered for a long period of time, unless we really identify the patients that truly benefit from such interventions. However, that said, I would say that certain immunotherapies have a place, and this could be either short-term interventions, such as short-term B-cell depletion, for example, with antibodies, or other biologicals, and still vaccination, actually. But for that, we need to really identify the right antigen, which is a major task. So as I mentioned, the RNA technologies could offer great opportunities for all these different treatments, actually, because they are modifiable and fast.
Thank you. We have a few more questions. If you had unlimited funding for one, let's say, crazy or high-risk project in atherosclerosis research, something you would not normally get a grant for, what would you do?
Yeah, I'm not sure if this is a crazy aspect, but it's certainly high risk and expensive. And so being a laboratory medicine physician, I really would like to find a circulating biomarker that better reflects plaque characteristics, such as inflammation or plaque vulnerability. And that probably would require a large number of patient samples, including plaque samples and matched plasma and excellent clinical data. And then I would try to analyze these by various omics technologies, especially proteomics, especially in the plasma and different plasma compartments, including looking at post-translational modifications, which can be done now, to identify potential biomarkers by integrating these data. And of course, this would be supported by machine learning and artificial intelligence, of course.
And this sounds very interesting. I actually wanted to come back to your statement about vaccination. Well, Can you elaborate a bit more? What's your vision on the role of vaccination and also immunization as a strategy to treat or maybe even prevent atherosclerosis?
Yeah, as I mentioned before, I think the major issue is identifying the right antigen, and we then need to find out whether vaccination against that antigen has really no potentially harmful effects, because often these are self-antigens, and one has to be very careful in dealing with the self-antigens, of course, and vaccinating against them. And I think that is the major issue here. So our own interests are, of course, modifications that occur in the context of lipid peroxidation, which alter self-proteins, and therefore we consider these to be attractive targets, as they would not target the native normal protein for that matter, but the modified one. And I think that would have potentially some merit. However, we also need to find the right approach, how to boost the right type of immune responses. Is it a type 1 or type 2 T-cell dependent response, or would it be better maybe to have T-independent expansion of certain immunoglobulins, but therefore in these cases you would need to keep boosting? So we don't know, but I think the key will be to identify an antigen that really is worth pursuing all these different studies.
That's really fantastic to hear. And is there a widely accepted idea in atherosclerosis research that you believe will be overturned in the next decade?
I think all ideas have their merit, and we in a way see them reoccurring in different ways. It's really the new methodologies and technical possibilities that we have which allow us to look at old concepts through different glasses. So I would not consider this to be overturning ideas rather than providing a better understanding of old concepts and ideas. And then one has to consider that atherosclerosis as a disease is changing. So while we used to see much more plaque ruptures before, we now see more plaque erosions, and we really do not understand a lot about the mechanisms behind this.
As we begin to wrap up, we have one final tradition on this podcast, something we call the graveyard of ideas. It's a way to honoring the less visible side of science, the failed experiments, the rejected grants, ideas that we love but we couldn't pursue.
So, Professor Binder, what would you contribute to our graveyard? Maybe a project that didn't work out, or a moment where things didn't go as planned?
Yeah. Well, there is a few ideas that are buried, but this doesn't mean that they are dead, I would say, but the time may have not been ready yet. So one example is a quest we had to understand the role of extracellular mitochondria in atherosclerosis, because we had shown that when activated macrophages, they can shed mitochondria, and you can find them in the circulation, and they are very inflammatory. But we still don't know how this is happening and how these can contribute to atherosclerosis, and this is quite challenging to investigate. So this is one of the ideas I would love to pursue. But in general, I think most good projects do not work out as planned. So this is what makes science actually exciting. So, but one must be honest and take this information very serious to tackle the next steps. And this will actually often bring the breakthrough findings, that you have an unexpected discovery which you take serious and then bring to the next level. So I would be hesitant to say that something did not work out, but I would rather say it worked differently. And there's certainly a few experiments that did not work out, if you mean it that way. One example is something that I did many years ago. I actually generated or tried to generate T-cell hybridomas with specificity for oxidized LDL as an antigen, because the goal was to ultimately then generate a T-cell receptor transgenic mouse to study the role of these T-cell responses, these antigen-specific T-cell responses in atherosclerosis. And I was actually really able to clone specific T cells, but I never could maintain them in culture. So in a way, this didn't work out, but maybe I should revisit this, actually.
I think it probably just worked differently.
Yeah.
I actually like this conclusion that something, if it doesn't work out, it actually worked out, but just different. So I think that also for all the young people good to keep in mind, like you say, that these are maybe the most interesting ways to also continue in the future. Before we finish, we would also love to hear your thoughts on navigating early academic careers. What would you say are key ingredients to success during your PhD and your early postdoc stage?
Patience. I think it is really key to be patient in the first years when establishing yourself as an independent academic. And do not fall for these quick wins, because your career needs to have a solid basis. And the way you establish yourself in these first years is really often the basis for how you will be perceived by the community. And very importantly, you need to stay really focused and identify an interesting topic that you would like to pursue, that is unique in some way, and you need to stick with it. And you also need to try to avoid all these other activities we discussed at the beginning of the podcast. They will come naturally when you get older, and then you will wish the old days back when you did not have all these responsibilities. So really patience and persistence are things that are very key in the early phase of your academic career, my opinion.
It's really great to hear your personal perspective. And finally, we would like to help connect researchers to opportunities, as you helped previously to us. So do you usually announce open positions in your lab, or would you recommend that interested candidates simply reach out directly?
Yeah, it's always a good way to directly reach out or approach me at conferences. For PhD student positions, we typically advertise them because we have a common call, but postdocs usually approach me individually by email or at conferences, and that initiates a discussion. And I'm happy for everyone to approach me.
Thank you so much, Professor Binder, for joining us and for sharing your time, your expertise and experience with us. We have learned so much from you today.
And of course, also huge thanks to all of our listeners. So this podcast is really made for you. So please let us know what you think. Feel free to suggest topics that you would like us to cover, and stay tuned for more episodes.
Yeah, thank you very much for having me. It was really fun.
Until next time, take care, stay curious, and keep pushing the boundaries of science.